Okay, so let us start today's topic. We have given enough time. So what we are going to study today is 8.4 graphical representation of motion. So we have started this subtopic in the last session only. We have gone through some part of it, but today we will continue with the same thing, that is 8.4, but much in detail by taking examples from our textbook and also from outside. So this is today part 2 of 8.4 itself. Okay, so graphs which are given in our textbook are these two ones. Okay, so let us just understand topics which are given in our textbook, but we are also going to see which is not given in our textbook. Fine. So topics which are given in our that NCERT base book is 8.4.1 and 2, which is standing for, one is distance time graph and another is velocity time graph. If you are asking me, sir, what kind of graphs will be asked in the exam? See, all sorts of graphs can be asked in the exam. They are open to ask anything. But our books deals with only these specifically two graphs. Let us try to understand more apart from these two. But these two will also see in detail. Fine. So let us see one by one. The first graph which we are going to see is distance time graph. We are not going to take any values. We are just going to understand right now that these graphs can be used for what exactly. Okay? What is the purpose of these graphs? Can we use them to calculate something? So first example we are going to take is distance time graph. Okay? Distance time. In short, in some books it would be called as DT graph also. Why DT graph? D short for distance D and time short T. So DT graph. So in some books they will also just mention that according to the DT graph. Okay? So you should not get confused while reading such kind of books. DT graphs just means what? Distance time graphs. So let us just assume that this is a distance time graph and this is a straight line. So we already know a straight line just means that that body is traveling in a uniform motion. That we already know. So let us try to understand what would be the area and slope of this graph. We already know how to calculate area. All we need to do is multiply whatever is present on y with whatever is present on x. Okay, so y value is distance, x value is time. So if we want to take area of this graph, it would be distance into time. Why distance into time? Because area of a graph is nothing but y value multiplied with x value. So distance into time, that is the thing. But there is no quantity which is given by distance into time. So let us just keep as it is. What about slope? Slope can be calculated by dividing y value with x value. So whatever is present on y has to be divided with x. So let me take that. So slope is equal to distance by time. Why? Because distance is present on y-axis and x-axis value is time. So y by time. That means distance by time. So in area we take multiplication of the two. In slope we take division of the two. That is the difference. Okay? But focus on this. There is no quantity which can be given by multiplying distance into time. But we definitely have a quantity which can be given by distance upon time. And that quantity we know by another name, that is called as speed. Okay? So slope is equal to distance by time, but distance by time is what? Speed. This formula, distance by time, is what? Speed. So that means if we take slope of distance time graph, we will get speed. Okay, so give me response in chat box. Have you understood that? Taking area will not give us anything, but if we take slope of this graph, we will get speed. Agreed? It's a simple thing. All we have to do is whatever you have learned in the last lecture, just apply that. Okay? Fine. So do one thing. Write this down in your notebook. Distance time graph. Write down the heading. Just draw these two lines, a straight line, just in short. Make it a very small one so that it will be completed in less time. And write down these 2 points. Area is equal to distance into time and slope is equal to distance by time, which can also be said as speed. So distance time graph, slope will give us speed in short. Write this down in your notebook. We'll give you some couple of seconds and we'll go to the next one. Once you are written, please let me know. because this is not just one graph we have to see today. We have to see at least 5 to 6 more graphs same as these, and also we have to solve blue questions. Done? Okay, fine. Now focus on this graph. Instead of taking distance time graph, now I am changing it to displacement time graph. Okay? So I am replacing distance with displacement. So let me take displacement and time. So I have taken displacement time now. Instead of distance, I have taken displacement on y-axis. Now area of again this graph, as the y value has changed, it will now become areas of this graph would be displacement into time, multiplication. So displacement into time. But again, I remind you, there is no quantity which can be given by displacement into time. So let us just keep as it is. Let us try to find out slope of this. Slope would be what? Displacement divided by time, right? Y by x. So slope would be displacement by time. Agreed? Give me a response in chat box. Do you agree that slope of this particular graph would be displacement by time? Right. What Aditya, what you are asking, would it be delta A by delta B? No, no, no. See, value of a slope is nothing but delta Y by delta X. But when the coordinates are not given, basically we are trying to find out Y value divided by X value. That is the meaning. So when coordinates are not given, actually what we are trying to find out is division of Y with X. So that is actually the meaning of it, underlying meaning. So displacement slope of this particular graph is displacement by time. But we already know the quantity. Which quantity can be given by displacement by time? Give me response in chat box. You already know this. Which is the value which can be given by displacement by time? Yes, Urjit is the first one to give answer correct. Answer is velocity. What about other students? No idea that displacement by time is velocity. Okay, fine. Chalo. Urjit, congratulations. At least you are being sharp and at least paying attention to whatever is being said. The rest of the students, please pay more attention. This is very simple. All you have to do is apply your mind. Okay? Just open it. So displacement by time is nothing but what? Velocity. So whenever we are talking about displacement time graph, slope of this graph would be what? Velocity. Write this down in your notebook. Make a second graph. ठीक है, make the same two lines, a straight one, displacement time, and write down area and slope of this graph, displacement time graph. So we have seen two graphs till now. ठीक है, write this down as well. Okay, once you're done, let me know, and let us check this time how many students are paying really their attention. Let us see. You have to give your answers when I'm asking you. ठीक है, so let us check again. Okay. So next graph which we are going to see is speed time graphs. Okay, speed time. So time we are going to say keep as it is, but we are going to change that displacement with speed. So new graph we have on your screen is speed versus time. So area of this graph is speed into time. Okay, obviously because y value with x value multiplication. So okay, area of this graph is speed into time. Now give me a response in chat box. Do we have any value which can be given by speed into time? Be quick, the student. Let us see who answers first. Is there any value which can be given by speed into time? Yes, Samruddhi is the first one this time. Answer given is distance. Okay. Okay, fine. Samruddhi, congratulations. Okay, so the answer is very much for this particular area is speed into time is nothing but distance, correct? So area of this particular graph is distance. Already we know. What about slope? Let us take slope for this. Slope can be given by y value divided by x value, that is speed by time. Okay? So speed by time. Now question is, do we have any quantity which can be given by speed by time? Okay? We don't have any quantity which can be given by speed by time, right? So we are not going to write down anything. Slope is equal to speed by time, that's it. So there is no point of taking slope of this graph speed time because it doesn't give any value. But area, if we take area of this graph, definitely we'll get distance. Okay. Please write down this graph in your notebook. We have to go for the next one now. We have to go for velocity time graph, VT graph. Once you have written, please let me know. Okay. Now let us go for the next graph. This is speed time graph. Okay. Let us go for the next one. That is going to be velocity time graph. So that is velocity time graph. This is the one, velocity time graph. So I have changed whatever was present on y-axis with velocity. So velocity time graph we have this time. And the area of this graph is going to be velocity into time. Okay. Velocity into time. Area. Multiplication of the both quantities. Now give me response in chat box. Do we have any value which can be given by velocity into time? Okay, who was the first one this time? Kushal. Okay, Kushal was the first one to give answer this time. So velocity and time is given by displacement. Obviously, velocity into time, there is one formula, velocity is equal to displacement by time. So when you multiply velocity and time, you will get displacement. What about slope of this graph? Slope can be given by velocity by time. But we don't have any quantity which can be given by velocity by time. So we'll keep as it is. So there is no point in calculating slope of this graph, but area will give us displacement. So write this down in your notebook, velocity time graph, write down its area, write down its slope. It's very easy to understand. See, all you have to do is in area, multiply both quantities, and in slope, divide two quantities. Itna simple. Start with y. Okay? All you have to do is divide y value with x value in slope. Area, all you have to do is multiply both of them. That's it. Okay. Written? Can we move to the next one? Last graph is remaining. This is velocity time graph. Last graph is remaining. That is acceleration time graph. Okay. So this particular thing, velocity by time, okay, velocity by time is nothing but what value we can be calculating. We can calculate acceleration. So from velocity time graph, there is one more quantity which can be calculated. That is velocity by time is what? Acceleration. So by area, if we take area of this graph, we'll get displacement. But if we take slope of this graph, we will get acceleration. Because acceleration you already know, that is change in velocity, rate of change of velocity. So basically it means velocity by time. So when you take slope of this graph, the answer you will get is acceleration. So write down there in your notebook, slope is equal to acceleration from VT graph, velocity time graph. Written? Aditya, what you are asking, it is change, but it is change in velocity, right? Just now I explained, Aditya. See, even if it means change in velocity, at the end of the day, what is going to happen? You are going to subtract the value in the numerator. So after the subtraction, what you will get is basic velocity. Doesn't matter. See, you are taking difference, but what ultimately you are going to get? Velocity only. So that means it is velocity by time. So basically, it is nothing but acceleration. And anyway, whenever you are calculating slope, you are taking which value? Delta y by delta x. Delta y means what? Difference. So that is nothing but the difference of velocity here. So we can say that the slope is acceleration. Okay. Now let us go with the next one. Last graph that is remaining is acceleration time graph. Now acceleration time graph is very simple. See, if we take its area, it would be acceleration into time. And acceleration into time means what? We have a formula, acceleration is equal to velocity by time. So acceleration into time would be velocity. So area of this graph will give us velocity. But if we take slope, what we are going to get is basically acceleration by time. If we take slope of this graph, we are going to get acceleration by time. which is not going to give us anything. Okay, so let us just skip as it is, acceleration by time. This last line you don't write, that is just some part is missing here. It is just after this it was written slash by time. There is no quantity which can be given by acceleration by time. So let us just keep as it is. But area, definitely. We can just multiply acceleration and time and we'll get velocity. So write this down in your notebook, and once you are done, let me know. Okay, we have to solve that blue question part as well today. Okay, Tanmay, what you're asking, will this happen when it's uniform motion? See, we are not taking example of these graphs for uniform or non-uniform. We are just taking formulas for this, so that whatever the condition might be, whether it can be uniform or non-uniform, we should be able to use these formulas to solve our numericals. For that, we are seeing these graphs. Till now, we have not discussed whether it is uniform or non-uniform. Doesn't matter. Okay, that will be discussing later after this. Okay, so let us go with the next thing now. So whatever the graphs we have seen till now are the complete graphs. So okay, so we have taken a distance time graph, we have taken displacement time graph, then velocity time graph, speed time graph, and last is acceleration time graph. So in all, I think we have seen 5 graphs. Okay, 5 graphs in total. 2 of distance displacement, 2 of speed and velocity, and 1 is of acceleration. The total 5 graphs we have seen. And in each case, we have seen how to find out area and how to find out slope. Now what we are going to focus is on the graphs which are given in our textbook. ठीक है, ये तो textbook के बाहर के हो गए. Now we have to concentrate on textbook graphs also. ठीक है? Okay. So the first graph which is given is in 8.4.1, and that is distance time graph. But let me check your knowledge. Give me response in chat box for my questions which I am going to ask right now. ठीक है? Distance time graph, if you are talking about, if we take um, slope of this particular graph, what we will get? Distance time graph slope. That is, what will be the answer? We'll get slope, right? What kind of slope will get? Speed, yes. Who gave the first answer? Madhura, okay. So Madhura is the first one to give answer. So that means slope of this graph will give us speed. But area, if we take of this particular graph, there is no point. There is no meaning, because that will simply be multiplying distance with time, for which we don't have a physical quantity. So let us see the graphs which are given in our textbook. So this is the graph which is given. So in this case, it's a straight line. Okay? It's a straight line. So that means that object is moving with a uniform speed. So focus on this. The graph title which is given in our textbook is distance time graph of an object moving with uniform speed. Let us check whether it is moving in uniform speed. First, we'll check whether it is distance time graph or not. Focus on y-axis. It is given distance. On x-axis, time is given. So that means it is distance time graph. So first point is ticked. Okay, it is distance time graph. Whether it is moving with uniform speed or not, how can we judge that? We have to judge that if that we have a straight line, it's a uniform speed. If it is not, then it is non-uniform. So do we have a straight line? So focus on this O to B. Definitely there is a straight line. So that means it's a uniform speed. Okay? Agreed that this graph is distance time graph and it's having uniform speed because of the straight line. Yes? Okay. Do not write down this. Okay, this is already present in our textbook. We are just discussing it. Okay, we will be solving separate questions based on these graphs later. Right now, just try to understand these kind of graphs. So this graph, what do you think? It's basically uniform or non-uniform? Can we say it's non-uniform? Because it's a curved line. It's not a straight one. Can we say it's a non-uniform one? Basically, it is what kind of graph? Non-uniform, because it's not a straight line. It's, you can see it's a curve. So definitely this is what kind of body? It's a non-uniform motion body. And this is what kind of graph? Distance time graph. Okay, so this graph is already given our textbook. And what these black dots represent? Black dots means what? That is the data which is given in the table. So that means some person might have taken the readings and he has given us the coordinates for x and y axis. So these points are nothing but coordinates. Like we have already plotted those, no, while solving that area and slope graph last time. So in the same way, that person has plotted these coordinates. So it's not something very, what I can say, very hard to understand. These are just coordinates. Okay? Let us not focus on it. Now, next graph which is given in our textbook is velocity time graph, 8.4.2, velocity time graph, VT graph. Now you tell me, if we take area of velocity time graph, what we'll get? Area of velocity time graph. If we take area, we will get displacement. Yes, we are going to get displacement because we are going to have what? Area of a graph means what? Velocity into time. We have a quantity based on that, and that is called as displacement. And what about slope of this graph? Slope of velocity time graph. What will we get? Tanmay, yes, you are the first one to give answer. That is very much correct. That is acceleration. So we'll get acceleration. So let us see the graphs which are given in our textbook. Is it a velocity time graph? So yes, it is velocity time graph. Velocity is given on y, time is given on x. So definitely it's a velocity time graph. Whether it's a uniform motion or not, so we just have to check whether it's a straight line. So you can see it's a straight line. So that is definitely what? A uniform motion. And what is this? This blue patch which they have given. So they are trying to find out area of this. In the textbook example, they have taken these coordinates a and b, and they are trying to find out area covered under it. So this graph is trying to calculate what? What do you think? If they have taken area of this graph, so give me a response in chat box what they're exactly finding out by this blue patch. What they will get from this blue patch. If they multiply the values of this rectangle, they will get Urjit, yes, you are correct. The answer which they are trying to find out from this is displacement. Displacement. Now the same thing, but for uniform acceleration. This graph is for velocity time graph and it's a uniform acceleration. How can we say that it's a uniform acceleration? Because you can see velocity is increasing by a definite pattern. It's a straight line, it's a velocity time graph. So that means this body is traveling with uniform motion, but as it is a velocity time graph, you can say this body is traveling with uniform acceleration. Uniform acceleration, straight line. Okay, so we have already seen these graphs in the last time we used to calculate area with the help of, we divided into two figures. One is called as triangle and another is rectangle. So in the both the cases, we added these areas by using formula of area of triangle, that is half into base into height, and for rectangle we use length into breadth. So that we have already done in the last session. Okay, so let us not concentrate on this. Now next graph which is given is velocity decreasing graph. Focus on this. This body initially, zero means what? At 0th second, okay, when the body started, it had the velocity of 20. Okay, so initially it had this velocity of 20 meter per second, but as soon as the time is increasing, you can see that velocity is decreasing. In here, this case is around something 15, then it went to 10, then 9 and 8 and 7, and it reduced to 0. Okay, so that means at 6th second, 0, 1, 2, 3, 4, 5, 6. At 6th second, this body had 0 velocity. So basically, it had 20 first, and then it reduced and it ended it at 0 meter per second. So that means this body initially was in motion, but after say 6 seconds, it completely stopped. It is not moving at all, and it has 0 velocity. So do you agree that if the line is, suppose, let's say in this way, if the graph is given in this way, it means that value is decreasing. Basically, that value is decreasing. Understood? Give me response. If such kind of line is there, it just means that the value is decreasing. That's it. Okay. Now focus on this graph. First, we have to judge whether it is uniform or non-uniform. So I have already written non-uniform. Let us just see why it can be non-uniform. For judging whether a body is uniform or not, first we have to see whether it's a straight line or not, right? But you can see, first it's a straight line, then it is decreasing. The straight line should be uniform for all the journey. but you can see from 0 to 20 in between, first it has increased, then decreased, then increased, then decreased. So such kind of thing we cannot call it non-uniform. Okay? But if you are talking about, suppose let us say if you are asking me, sir, for this patch, for first line, second line, and third line, if you are just talking about third line, if just third line, we are forgetting everything, that fourth line, second, and first. Just if you are considering the third line, can we say that for this particular 3 points, this particular moment, this body was in uniform motion? Definitely we can say that this body is in uniform, but only for parts of it. If we move from that third point to the next one, then it means again it is in non-uniform motion. Okay? So if you're talking about total body, then it is definitely non-uniform. But if you're talking parts of it, okay, you can see it's a straight line. So that means parts of this body were traveling in uniform motion. So understood the difference, that if we take parts of this body, it can be non-uniform, but if sorry, uniform. But if we talk about complete body, definitely it's a non-uniform variation. Okay, so what we are going to do now is we are going to solve some of the blue questions which are there. But before that, some things which I want to tell you is what we are going to assume in this lesson. The first thing we are going to assume is all the numericals which are given in our textbook, that is this complete lesson, there are different motions. See, in from 6th standard and 7th standard, you have been taught there are different motions. There is rectilinear motion, then there is circular motion, then there is projectile motion, then there is circular motion, then there are what I can say, there are so many motions that we cannot even list them. But in standard 9th, we have to talk only about motion which are happening in a straight line. Because see, even if we talk about straight line motions, there are almost 1D motions, 2D motions, 3D motions. So almost, let's say, in all, even in a straight line, we have almost 6 motions. So what we are going to concentrate on is only one kind of motion, that is motion in a straight line. That is the first thing. We are not going to discuss any another motion. We are going to just concentrate on motion in a straight line in our textbook, because this lesson is all about straight line motions. We don't have those motions, projectile motion or another motions. Okay? Second thing what you have to assume is distance is equal to displacement. Okay? That is the second thing which you have to assume while solving numericals. Unless and until they say you that there is a difference between distance and displacement, both the values have to be taken same. Because sometime what they will do, they will give you, suppose let us say speed time graph. Okay? They will give you speed time graph and they will ask you find out displacement from this graph. So you should not get confused. How can we find out displacement from this graph? Because from speed time, we can just get distance. What they are assuming in this case is distance is equal to displacement. And why we have to assume this? Because this lesson is all about straight line motion. And in straight line, we are assuming that the object is traveling in a straight line. It is not coming back. That is what we are assuming. That's why distance has to be taken equal to displacement. Unless and until they say in the question, please take distance is equal to displacement. And in the same fashion, you have to take velocity is equal to speed. Unless and until they say you that velocity is different and speed is different, till that time, do not take them separate. Take them same for speed and velocity. Okay? Because this motion is a straight line motion. So give me response in chat box. Have you understood the assumptions we are taking while solving numericals? That first it's a straight line motion, second distance equal to displacement, and third velocity is equal to speed. So unless they say you that they are different, do not take it otherwise. Okay. So let us try to solve blue questions on page 107. So please write it down. Blue questions page 107. Blue questions page 107. Write down this title in a notebook and we'll solve it right now. Okay. So first question which is present there is, what is the nature of the distance time graph for uniform and non-uniform motion of an object? Okay, so let me write it down. So first question is, what is the nature of the distance time graph for uniform motion and non-uniform motion of an object? What is the nature? What basically they're asking is, what kind of line do we get from these graphs? Distance time graph for uniform and non-uniform motion. If we draw them, what kind of line will we get? Give me response in chat box for distance time graph. What kind of line will you get for uniform and non-uniform? For uniform motion, will we get straight line? Correct? Yes, Madhura is right. Tanmay is right. we will get a straight line. And for non-uniform motion, it's not a straight line, right? So we already know this, so let us just write it. So this is the kind of graph we can get. This is your answer which you need to write down in your notebook. Okay, so first we have to take distance time graph, and for uniform motion, so basically for uniform motion you need a straight line, and for non-uniform motion it can be a curved line, or another way to write it is not a straight line. So even if you use curved line, I will still give you marks. Even if you write down not a straight line, still I will give you marks. Simply put, for uniform motion all you need to write down is if we get a straight line, and for non-uniform motion we get a curved or not a straight line. Okay, please change these words here. Okay, it is written distance time graph for uniform motion. Write down non-uniform motion here. Put a word non here. Okay, I forgot to write down that. So please write it. Distance time graph for non-uniform motion is a curved line or not a straight line. So these are the graphs which you need to draw there. Once you are done, let me know. Just you have to draw these graphs and mention for uniform motion we get a straight line, and for non-uniform we get a curved or not a straight line. Very simple. Okay, even a kid can do it from 8th or 7th grade. Okay, done. Can we move? Okay, so let us go with the second question now. Second question is, what can you say about the motion of an object whose distance time graph is a straight line parallel to time axis? Okay, so they are asking us, first draw a distance time graph in which there is a straight line parallel to time axis. So let me just draw it. So this is the graph, right? They are asking us to draw distance time graph and draw a straight line parallel to x axis, that is time axis. So this is the line. Okay, this is the graph. And what is the meaning of this graph? Meaning of this graph is that even if time increases, you can see 1 2 3 4 5 6, if you place numbers here, even if the time is increasing, distance of that object is remaining same. That means time is increasing, distance is not changing. This means that object is not moving at all, that object is at rest. Okay, basically it means what? That no change in the position of this object is happening, and hence this object is at rest. Time is increasing but the distance is not changing. Basically it means object is at rest. Very simple. So we have drawn first the graph, and we have drawn a line parallel to time axis. So you can see time axis is this, and parallel to this one is this one, this distance line. Okay, so write this down in your notebook and then we'll go for the next one. Urjit, what you are saying, can it be a uniform motion? Definitely, it's a uniform motion. Even though the body is not traveling at all, but still the distance was kept same at each time. So this particular graph is of uniform motion. Yes, you are right in that case. Okay. Can we move to the next question? Okay. Now the third one. Third one is, what can you say about the motion of an object if its speed time graph is a straight line parallel to the time axis? Okay. So first we have to draw a speed time graph and straight line to the time axis. So this is the graph. Okay. We have drawn the graph and we have taken parallel axis to time. So what is the meaning of this? That the speed is not changing with time. There is no change in the speed. Okay. That is what basically is the meaning of this. And what can then we say? That this indicates the uniform motion of the object. Speed is not changing of this particular object, and this object is in uniform motion. Okay. Fine. So